This is the fourth point, and actually what we are doing, see here, we are just drawing the electric field line for different types of system. For isolated positive charge, for negative isolated negative charge, for dipole, these types of electric field lines, for two equal positive charges, these types of, this is the neutral point. Neutral point is a point at which the electric field is, net electric field is zero. And for two unequal charges, for two unequal charges of same sign, two unequal charges of same sign, unequal means either one charge will be greater than another, or another charge will be greater than one charge. So in this case, the neutral point will be closer to the smaller charge. Neutral point, this is, see here, if you are taking this distance d1, this distance d2, then d1 is greater than d2. d1 is greater than d2. So now we will draw the electric field line due to a two unequal negative charges. Two unequal negative charges. See here, I am just taking two unequal negative charges, opposite charges. Two unequal, two unequal opposite charges. We have to draw the electric field lines. So I am just taking a one charge here and another charge here. This is Q2 and this is a positive charge, this is a negative charge, and the magnitude of charge Q1 is greater than Q2. Magnitude of Q1 is greater than Q2. So you will see the electric field lines. We know that the electric field line emerges from the positive charge and terminates at the negative charge. Like this. Like this. Emerging from positive charge, terminating to negative charge. But here there will be a neutral point. There will be a neutral point here. We have discussed the neutral point in detail. So due to this neutral point, what will happen? The electric field line will emerge from this and it will become like this. The electric field line will emerge like this and it will become like this. Means I have told you the electric field line will never touch the neutral point, never intersect the neutral point. N is the neutral point. Neutral point. And here is the neutral point. You will see, you can check this also. Take up plus Q1 charge and here is a minus Q2 charge and here is a, so here is a point. Due to this charge, the direction of electric field is in this direction, E2, and due to this charge, the direction of electric field is in this direction. So neutral point will lie either this side or this side. So okay, fine, that is. If you have a conductor, like this, if you have a conductor like this and a positive charge is placed here, a positive charge is placed here, then you will see how the electric field line will emerges from this positive charge. So the electric field line will be like this. This is the positive charge. So due to this positive charge, This is just the conductor. Due to this positive charge, negative charge is induced on the surface this side. An equal amount of positive charge is induced this side. Due to this positive charge, negative charge is induced this side on the conductor, and equal amount of positive charge induced on this side. So the electric field line will be like this. Like this. The electric field line will be like this. And we know that and from here the electric field line will emerges like this. We have discussed that electric field line cannot enter inside the conductor. And these lines will be perpendicular to the surface of conductor also. I have already discussed this. These lines will be perpendicular like this. So here you can see the electric field line originating from positive charge and terminating to negative charge, and here is a positive charge, and from here the electric field lines are originating. Now if you have a conductor again, seventh point, Bhumi, are you getting?
Yes, sir.
Okay, fine. So again I am taking a conductor here, and at a certain distance from here like this, a positive charge is placed. So what will happen? Here a negative charge will be induced. Due to this positive charge, a negative charge will be induced on this surface, on this side of the conductor, and an equal amount of negative charge, here an equal amount of positive charge will be induced on this surface of the conductor. But now what I am doing, I am just earthing this conductor. Earthing is represented like this. Earthing means all the charge will move towards the earth. All the charge, we will connect a wire from here, and from here we will take all the charge, and this all charge will go into the earth. So here this positive charge will be no more because of earthing. We have done earthing, and now this positive charge is no more here. This is gone somewhere inside the earth. This is earthing. So due to the, if this is the condition, if you have a positive charge and if you have a conductor and this conductor is earthed from one side, then the electric field line will be like this, emerging from this like this, like this, like this, and like this, and these are perpendicular to the conductor. Now here is no charge, so no electric field line will emerges from this side, as in this case. And if you want to draw the electric field line for the uniform electric field, if the field is uniform electric field, uniform means electric field is same everywhere. So in this way you can draw this type of field lines represents the uniform electric field. These types of, because if you this the distance between the lines will is same, and the length of this line is also same. This distance is the, this distance is the, and this electric field is uniform. This electric field is uniform. So these are the properties of electric field line. So Bhumi, please note it down. These questions can be asked in your examination. Draw the electric field line for the conductor when a positive charge is placed near it. Draw the electric field line for a conductor when a positive charge is placed near it and the conductor is earthed from one side. Draw the electric field line for two unequal opposite charges. So please note it down. And after that we will start force on the charge particle in electric field.
So this is done.
Done. Completed this one and this one also.
Yes, sir.
Okay, very good. So now we have the topic force. We have the topic force on the charge particle, on the charge particle in electric field, in electric field. So if we have a uniform electric field, if we have a uniform electric field like this is the uniform electric field. Uniform electric field. This is the uniform electric field. Okay, now this is the uniform electric field. E is uniform. And if you are placing a charge can be two type, positive or negative. If you are placing a positive charge, suppose you are placing a plus Q charge in this field, then due to this electric field, an electric force will be applied on this positive charge in the direction of electric field, and this force F is given by the magnitude of the charge Q into electric field. If you want to write this in the vector form, you can write charge into electric field. Now if you are placing a negative charge in this field, then the force on this charge will be opposite to that of electric field. So this force, the magnitude of this force is again QE, but if I am writing this in the vector form, then I can write minus Q into E. So on positive charge, on positive charge, this force is equal to QE on negative charge. Force is equal to minus Q and E vector. And here you can say that direction of force, see, the direction of force is opposite to that of electric field. Electric field is in this direction and force is in this direction on the negative charge. So direction of force is opposite to electric field, and here direction of force is same as that of electric field. Direction of force is same as that of electric field. This is direction of F. F means force is same as that of electric field. Getting? So note it down. Noted? Please note it down. Bhumi completed?
Yes, sir.
Okay, good. Now we will discuss the um, we will now place the dipole in electric field. We will now place the dipole in electric field. Dipole in electric field. So Bhumi, tell me what is dipole?
Consisting of opposite charges separated by a small distance.
Yeah, very good. So, and please remember this formula. This is for uniform electric field only. Now we will place the dipole in the electric field. and we will see what will happen. So I am just taking a uniform electric field. This is the uniform electric field is represented by these types of parallel lines, equally spaced parallel lines, equally spaced parallel lines. This is the uniform electric field. E is for electric field and this is uniform. Uniform, what is the meaning of uniform? Uniform means throughout the length, throughout the area, the electric field is same.
It stays the same.
Yeah, uniform means same. Electric field here, 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 all at all the points the electric field is same. That is the uniform. So now we will place a dipole. We will place a dipole. So suppose I am having a minus q charge here and a plus q charge here. Plus q charge here, and this system is known as the dipole. This system is known as the dipole, a system of two charges separated by some distance. And this is the center of dipole. This is the center of dipole, and I am assuming this point Q is at A and this point plus Q means point charge plus Q is at B. So Bhumi, you can see here that two charges are placed. Two charges are placed in the electric field. This is the positive charge and this is placed in electric field. So the
Yes.
force, yeah, so the force will be like this, in this
Yeah.
direction, yeah, in the direction of field.
Electric field.
Yeah, so the force on this charge will be in this direction, F, and on this negative charge, the force in the opposite direction of electric field, force, and the value of both the forces F is equal to charge Q into electric field. The value of this force and this force, if we are talking about the magnitude only. And see here, direction of this force is in this direction and direction of this force is in this direction. So on this dipole, two forces are equal and opposite. On the dipole means you can say net force on the dipole F net means net force. Net force on the dipole. We have discussed this in the vectors. When two forces on a system equal and opposite, then net force on the system is subtraction of both the forces, that is 0. Here also, when you will calculate the net force on the dipole, you will get F minus F, that is equal to 0. Net force on the dipole is equal to 0. But here one thing more. This dipole, suppose I am just drawing a line parallel to the electric field from the center of the dipole, and the distance between this charge and this perpendicular on distance between this charge and this point is r. Same is the case here. Same is the case here. This distance is also r due to the symmetry. And we know that this is very important point, please. If two forces are acting like this, and this is a center, so due to these two forces, this system will rotate. Like this is a dipole, like this. See here, this is a dipole like here. And now someone is applying a force in this direction, and someone is applying a force in this direction, and another person is applying a force in this direction, means this pen will try to rotate like this due to both the forces, if both the forces are equal.
Yes, sir.
Yeah. And this rotation is formed due to the couple. Here in this case you can see here F net on this system is 0. There is a center O. On this system AB. AB is the system. On AB system is 0. If net force is 0, then translational motion will not be possible. Suppose this is a pen and someone is applying a force F in this direction and someone is applying a force F in this direction. So this pen will not move like this. This will rotate like this. So translation motion will not happen, but the rotation motion will happen. But due to equal forces acting at different line of action, in opposite direction, a torque is produced. A torque is produced. Torque means the system will try to rotate like this. Okay. And we have the system here. We have a system here. Here positive charge is placed. I'm just placing a positive charge on V. On V, there is a positive charge. On A, there is a negative charge. And this distance is R and this distance is R. This is a dipole whole system. And that torque is given by, if you will calculate that torque, the formula of torque is force multiplied by the perpendicular distance from the axis of rotation. Perpendicular distance from the axis of rotation. So see here, this dipole is rotating. This is a dipole. If this is suppose is this is a dipole, then this is rotating with the center point. Means this dipole is rotating with respect to this point. Dipole rotating with respect to O. So we will take the value of torque, 1 of the force multiplied by the perpendicular distance. This is the perpendicular distance. You can, R is the perpendicular distance from the axis of rotation. F cross R. Not cross, F multiplied by R. F multiplied by R. F is a force and R here is the perpendicular distance from axis of rotation. O, the axis of rotation is passing from O. Okay. And the direction of electric field is in this direction. Electric field is in this direction. So if you, and I am representing this torque by tau, this is tau, and this torque is given by force. Force is Q E, and the perpendicular distance is R. So torque is QE into R. Torque is QER. Torque is QER. Now this dipole, if making angle theta with the electric field, this is the dipole, and this dipole is making an angle theta with the electric field. Making an angle theta with the electric field. So I can write from this triangle, if you will take this triangle, from this triangle, suppose this is a triangle OAB, OAC. So this is figure 2. I am writing here. In figure 2, from triangle AOC, AOC, you can calculate the value of R. So see here, if you will calculate sine theta is equal to perpendicular divided by hypotenuse AO, and this AO is A, this OB is A, this distance is A, this distance is A. Earlier we have also taken this distance. So in triangle AOC, if you will calculate the sine theta, then sine theta will be perpendicular divided by hypotenuse, and perpendicular is R, hypotenuse is A. So you will calculate the value of R is equal to A sine theta. Now you will put the value of R here. So tau will become QE R. Instead of R, you will put A sine theta. You will put A sine theta. Just wait. This is sorry. So now instead of this triangle, I am taking the another triangle. We have dipole like this, and the direction of electric field is like this. This is the direction of electric field, and this is the dipole minus q plus q, and this electric field is making an angle theta, and this is perpendicular. I am supposing this as O. What is this here? This is AB. This is AB. This is A. This is B, and you can take this. Sorry, this is O, and this distance is 2. Sorry. So we know that in case of dipole, we take the distance between the two charges as 2a. 2a, this distance is 2a here. See here, this distance is a into a plus a. This is 2a. So if you will calculate the value of sine theta, then you will get this r perpendicular. R is the perpendicular distance and divided by 2a. Then from here you can calculate r. R is equal to 2a sine theta, and now put the value of r here. Tau is equal to QE, and instead of r put 2a sine theta, and now we have E, we have Q into 2a, and we have sine theta, and dipole moment is Q into 2a. Dipole moment, this is dipole, P is dipole moment. This is dipole moment, and tau here, from here we can write, this is P, this is E, this is sine theta. So torque generated when an electric dipole is placed in electric field is given by Pe sine theta, and theta is the angle, P is the dipole moment, E is the electric field, E is the electric field, and theta is the angle between, theta is the angle between electric field and dipole moment. Sorry. So please note it down. Please note note it down. Bhumi, are you writing? Okay. Please write.
So done.
Done. This one completed.
Yes, sir.
This this is completed.
Yes, sir, the diagram.
Okay. So torque generated when a dipole is placed in the electric field is given by Pe sine theta. P is the dipole moment, E is the electric field, theta is the angle between the electric field and dipole moment. Written. Are perpendicular. This is R perpendicular. R perpendicular. You can write it. And please change one thing here. Perpendicular distance between line of action of two forces. Line of action, lines of action of two forces. Completed, Bhumi?
Yes, sir.
Okay. So when you will place the dipole in the electric field, you will get a torque of tau is equal to P sin theta. Tau is equal to P sin theta. Now, case first is when electric field E and dipole moment P are parallel. When E and P are parallel means electric field is like this. This is electric field, and dipole is also like this. Dipole moment is also like this, and theta is the angle. Then theta will 0 degree. I am just coming. Theta is the angle. So we have torque is equal to PE sin theta. So in this case, torque is equal to PE. Theta is 0 degree. So we will place sin 0, and the value of sin 0 is 0. So torque is PE into 0. In this case, the torque is 0. In this case, the torque is 0 when electric field and dipole moments are parallel. Case second, when electric field and dipole moment are anti-parallel. See here. So means when anti-parallel means electric field is in this direction and dipole is opposite to this. So in this case, electric field is in this direction and dipole moment is in this direction. Theta is equal to 180 degree. And when you will calculate torque, that will become PE sin theta. PE sin 180 is again 0 degree. So torque is also this time also is 0 degree. But this is a case of unstable equilibrium. and this is the case of stable equilibrium. Bhumi, do you remember we have discussed the three types of equilibrium: stable equilibrium, unstable equilibrium, and neutral equilibrium.
Yes, sir.
Yeah. So, okay. Case third, when electric field and dipole moment are perpendicular. This is very simple. Means the electric field is like this. Electric field, if electric field is in this direction, this is the direction of electric field, and the dipole moment is in this direction. P, this represent, and the angle between them is 90 degree, and when you will calculate torque, P is sine theta, then torque will be PE sine 90, and sine 90 is equal to 1. Sine 90 is equal to 1. This will become PE, and this PE is the maximum torque generated by the dipole. This is the maximum torque generated by the dipole. Maximum torque. When you will place the dipole at an angle 90 degree with the electric field, then maximum torque will be generated by the dipole. Here torque is 0, here torque is 0, and okay, note it down. Already noted, or do you want to note it down? Please tell me. Bhumi, hello.
Yes, sir.
Have you written this?
Yes, sir, in case 2.
This P vector is the dipole moment. Written?
Yes, sir.
So in today's class, we have discussed the force on the charged particle in the electric field. On a positive charge, the force is in the direction of electric field. On the negative charge, the force in the force is in the opposite direction of electric field. The magnitude of force is given by QE. If you want to write in the vector form, this is, if you want to write the force in the vector form for negative charge, this is direction of force is same as that of. So now we have and after that we have discussed the dipole in the electric field. When this is the dipole and we have placed the dipole in this in the electric field, and theta is the angle the dipole making with the electric field. One thing to note it down, the direction of electric field is this and direction of dipole movement is this. Okay, dipole movement is this. Dipole movement is from negative to positive charge. The direction of dipole movement is from negative to positive charge, and theta is the angle. And dipole in, when you will place the dipole in the electric field, a torque will be generated. A torque will be generated, and that torque, the value of that torque will be, and tau here is the torque. Tau here is the torque, and that torque is given by P sine theta. And now after that we have three cases: 90 degree, 180 degree, 0 degree. Bhumi, that's all for today. Now you can leave the class, and thank you for joining. And please revise your notes also. Hello Harsh, how are you?
Fine, sir. How are you?
Okay, I'm also fine. So actually you have done the in the test you have done these three questions correctly. This question,
Yes, sir. And the fourth one, I didn't hear.
this one, and this one. And there is
Yes,
a
sir.
little bit of calculation mistake. That is fine. But I am discussing the question number 4. This is
Okay.
a kind of good question, you can say, and I am just discussing it. So
Yes, sir.
yeah. So see the question that here two charged sphere. They are saying that two charged spheres. They are saying that there are two charged spheres. There two charged spherical conductors of radii r1 and r2 when connected via connecting wire. What happens? See here. Here is a charge conductor, and here is another charge conductor. Okay. Spherical. This is sphere 1. This is sphere 2. This is spherical conductor 1. This is spherical conductor 2. Conductor 2. And now they are saying initially they have some charges. Initially they have some charges, but they are not connected with some wire. Initially they have some charges, and they are not connected with wire. Suppose this have a charge of, earlier the charge is of plus q1 and charge of q2. I am just supposing. Plus q2. Not, you can take, it is not necessary to take plus sign or minus sign. Whatever is the charge, earlier there was charge, but now what happens? Both the spheres are connected by wire. By the connecting wire. See what happens. Now this system is connected by a yellow color wire, conductor wire, and they are saying after connecting with wire, they have charges q1 and q2. They have charges q1 and q2. Oh yaar, Harsh. So Harsh, I have so this is the question. Two charges spherical conductors of radii r1 and r2 when connected via, this spherical conductor has radius r1,
R1.
this has the radius r2, and after that they have connected with some wire, and after connecting the wire they have charge q1 now, sphere 1
Yes, sir.
have, and sphere 2 have the charge
Q2.
q2 now. Very simple. So what will happen? Earlier there are some charges. So when you will